Hello, folks. Welcome to the Tech Talks for Splunk. And I think on this slide, you will see all the logistics-related information that you should be aware of. In case you're not hearing any audios or having some problem with the connectivity, just follow some of those bullets on the bottom of this slide. Okay. With that, let me move on. Okay. So today we about the event intelligence, but specifically focus on how we can turn the network alerts into actionable signals using Splunk, and specifically the IT service intelligence module of Splunk. Just for the introduction's sake, I'm Tapan Shah. I'm a director of product for Splunk Observability, and I'm joined by my colleague, Matthew.
Hey, I'm Matthew Hanlon. I'm a senior technical leader here at Splunk and Cisco, and I lead the content packs and integrations work, and have been developing a lot of the networking integrations between Cisco networking solutions and ITSI.
Okay, so with that, let's look at what is it that we are going to talk about today. So we want to start with the challenges that we hear from our customers when it comes to incident management. And then we'll talk about how Splunk approaches it, specifically for network alerts, right? And then we will also talk about everything that we'll see. We'll talk about how much of that is coming out of the box versus what requires any custom efforts. And then we're going to end that with the demonstration. And of course, towards the end, there will be Q&A. So with that, let me move on and talk about the common challenges in incident management. So this is what we see and hear from the top operations team that we actually end up talking to. And these are the statistical information from 2023-24 timeframe. In the last 5 years, there is almost 3x increase to the number of alerts that the large organizations need to process. 84% of those organizations actually say that, hey, event correlation is their top needs. And the more time they take to resolve the outages, this is the sort of the revenue impact that they are facing. So for these statistics, when we dive in from the statistical data to the actual technical challenges, to understand what is really slowing those operations teams down, these are the three categories or the pillars of challenges that we hear from our customers. One is, hey, we have a lot of fragmented visibility or the visibility silos. Our apps infra and network teams are always working on their disjoint set of tools and their own spaces, their own silos. And that just results into understanding of the big picture and how things are connected end to end. So that's like number one challenge category. The second is, because of that particular challenge, the troubleshooting itself is fairly reactive, takes a longer time. When an issue happens, it just takes way too long to kind of troubleshoot, triage, identify the root cause, and actually resolve it. All that pretty much leads into the war room chaos because there is pretty much no shared context. I mean, this is sort of the core trigger, the visibility gap, which leads into the war room chaos as the outcome. And then that starts resulting into the finger pointing between networks, apps, and infra teams. So with that, what we are actually observing, right, like when it comes to the war room chaos, is this particular process in the incident management. Some change happens or something goes wrong and an incident occurs. After that, there are a series of these hypothesis steps that are required. The first thing that's required or is very important is the detection of the issue itself. Is this really an issue? Is this important enough? Is this something that we need to act upon right now? Right, so that is the whole detection and the prioritization of the issue. The second category of the investigation here is that, okay, once I detect where the problem is and where the issue is, how do I isolate the domain? if my applications are slow, how do I determine if this is truly an application stack issue versus is this coming from a network connectivity, right? So how do you isolate the domain and then ultimately diagnose and identify the root cause analysis? Root cause. Once the root cause is identified, how do you respond in terms of remediation of the issue or of the incident itself? So that's and this whole process, if you see like on this slide, it looks relatively simpler, but if you are in the operations or the IT teams, you would be able to recognize that it's actually a very complex, long time consuming process. And that's the process. These are the sort of challenges that we try to resolve with the Splunk solution. So when it comes to Splunk's observability, we serve various use cases right from the application monitoring to infrastructure to digital experience monitoring, all the way taking it to AI ops for event intelligence and even understanding the business impact of IT issues. For these varieties of use cases, we have various components of our solution. Our solution is backed at the foundation by Splunk's platform. This may be this is the platform that you are aware of, where you can bring the large metrics events data and in one single place, and then it helps you make sense out of that data. And we'll talk more about that on how we do that. So that's sort of the foundation of the solution. Then we have App Dynamics, which is optimized for 3-tier and tier traditional environments monitoring, and we have Observability Cloud, which is optimized for cloud native environments monitoring. And then on top sits IT Service Intelligence, which think of that as your single pane of glass or the AI Ops solution, which brings data from not only from the Splunk or Cisco managed environments, but also from the third-party systems all into one single place. Right, so that's pretty much what we are going to focus about, this particular component at the top, because that's where the event intelligence, the service intelligence aspects come into play. So with that, let me move into the next slide. So now, think of how we orient. So what we just saw was the portfolio. Now, how does that portfolio get oriented to network observability as a use case or workspace with Splunk, right? So Splunk becomes part of Cisco. It's been like a little over 2 years now. And then what we have done so far is that bringing all the network telemetries from Cisco's core networking technologies. So if you see on the left side, we are covering the Cisco's enterprise and the data center networks through all these technologies. So if you look at Catalyst Center, SD-WAN, Meraki, and ThousandEyes, that largely covers the enterprise networks, and the UCS Insight and Nexus dashboards covers the data center networks. And now with Splunk, we have an ability to bring this data into Splunk and then serve 3 distinct set of use cases. One, the network performance monitoring, right? Which is how does network event impact the user experience or the applications that are running on top of that network? Second, how do I improvise the performance of my application and the infrastructure? And third, and an important aspect is when a network or IT goes down or has bad health, what is the real impact on the business? It's almost like answering the so what question. Hey, we have a network outage, so what? Like what is it that it's really impacting? If it's a test network outage, it's not as much of an impact versus a particular site going down and actually impacting your businesses in terms of revenue and more. So those are the 3 dimensions in which we talk about when it comes to network observability with Splunk. So now from there, moving on to, as I mentioned earlier, when it comes to the network observability or bringing Cisco's network data into one single plane, it's the Splunk IT Service Intelligence solution that's kind of front and center of that. Now, as part of the introduction of that solution itself, for those who are not yet aware or have not seen it, these are the 3 core use cases that IT Service Intelligence serves. The first use case is the alert noise reduction, right? So you have alerts coming from your own monitored system or coming from third-party monitoring system. How would you consolidate and bring all these alerts into one single place, normalize those, enrich those alerts with more context, and eventually correlate those in a cost-income relationship so that you only act on incidents that matter, right? So instead of, let's take an example. you had a particular change, like an ACL change on a network device, right? And that started resulting into your servers getting connectivity issues. Those servers had databases running and some applications posted on top of that. All these are now starting to face latency or some sort of timeout issues. You would have a variety of monitoring systems that are monitoring all these components of your solution, and you basically would start all these various domains would start alerting on these various signals. Now there may be 30, 50, 100, or sometimes even 1,000 alerts, depending upon the extent of the failure or the impact of the failure, or the blast radius of the failure, right? Now, one way is, hey, I'm going to get everything alerted and I'm going to pick it from every alert, and then I'm just going to get my operations team go crazy. Instead, what we do is we bring all these alerts, we look at the context that they carry, and based on that, we correlate and group them so that you have one single actionable incident for a scenario that I explained. You don't really need too many things. I mean, the root cause here is predominantly the ACL change on the network device that has this, that was the first avenue, and then that's the chain reaction that just follows. So that's the core use case that we serve, and that's what we're going to talk about at depth as well today. The second is, how do you correlate the business KPIs with the IT KPIs? KPI here is a key performance indicator, which is nothing but think of that as a metric. You have IT metrics such as resource utilization, whether it's a CPU, memory, disk, etc., or you could have technical KPIs which are measuring the latency, response time on the network side. It could be packet loss, jitter, etc. How would you relate the performance of those metrics with the performance of your business KPIs, such as if you're a retail store and you want to understand the consistent trend of shopping experiences inside of the store or through your e-commerce or the online portal, then how would you relate those business KPIs with the technical KPIs? In other words, when things go wrong on the IT side and the technical metrics go south, what is the real impact on that on the business metrics? This could be customer experience, this could be customer satisfaction, this could be actual revenue or the dollar impact, right? So that's what the second use case is about. And then last but not the least is we also help you move from a more reactive to a proactive posture, right? Reactive troubleshooting is something went wrong, an incident occurred, and now everybody is coming into the war room and trying to resolve that incident. The proactive troubleshooting is you actually get ahead of the situation where you are able to then predict a potential incident or an outage based on the historical trend of your metric data. And that's what we do. We do the predictive health analysis to basically tell you 30 to 45 minutes ahead of time if you are planning to have any potential outage or an incident in your vicinity, right? So that's what the three core use cases are. These use cases align with these five core elements when it comes to AI ops or event intelligence or incident management. So how we do the incident management is like we first focus on anomaly detections. We look at the historically trending metrics data, we baseline them dynamically, and based on that, we basically give you a more accurate posture of anomalies, right? Where 11 o'clock every Monday, if there is a certain spike of traffic that is expected in your environment, that's just normal. So instead of alerting on a very static way, we would basically apply dynamic baselines with standard deviations, and we would form our opinion based on how historically the data has been trending within your environment, right? So that's what the anomaly detection is. The second type of anomaly detection that we support is also proactive anomalies. Think of an early warning system where, let's say, your applications have 10 milliseconds latency today. 6 months down the line, they become 100 milliseconds. So there is a 10x increase in the absolute latency measurement. Between 10 to 100, it's not a big deal. But when that happens, how would we be able to look at that historical data, the trend of the slowly growing measurement over a long period of time, and then tell you that, hey, if this trend continued, you may have a potential incident in occurrence, right? So that's what we call it as proactive anomaly or early warning systems. In the product itself, that capability gets exposed with what we call it as drift detection. After anomalies are detected, alerts are generated. The next step is alert noise reduction. And as I said, this is not just limited to what Splunk or Cisco can monitor and manage, but we are also able to do the noise reduction with third-party alert data. Then getting an incident ready so that you can actually apply the root cause and triage and troubleshoot the problems with the root cause analysis. Once the root cause is identified, the next step is how do you automate and remediate the problem for resolving it, and eventually learn from that behavior and extend it to getting a little more proactive about stopping an incident from occurring rather than always reacting to an incident. So with these core use cases, let's now see how this whole thing applies to network data and what we call it as network service health, where we are representing the health of a network in context of a service. So instead of telling you that, hey, you have these many wireless controllers and these many access points, and these are the access switches to which your APs are connected, I mean, that's just a network device level information. But what really matters is that when things go wrong at the APs or controller level, is my Wi-Fi service down, right? So think of Wi-Fi as a service that you provide to your customers, and is that down? And that's the posture that we give. And to give that posture, these are the kind of components that we integrate. So we are able to integrate Cisco's Thousand Eyes, Catalyst Center networks, and then the Nexus dashboards and ACI for our data center networks, and provide you this end-to-end use cases for cross-domain alert correlation as well as the fault domain isolation, right, with the combination of Splunk and IT service intelligence. We are also able to bring the SD-WAN data into Splunk platform for the log analytics based on the SD-WAN information. As I said, what our service health solution delivers is it's the cross-domain insights. It's actually helping you answer a question like, is your application slow because it's bad code or because it's a network issue like DNS or latency or whatnot? Largely oriented for the level 1, level 2 network operations team, the IT operations team, and the service owners and the business stakeholders. A lot of this, that the solution that we provide also comes out of the box. So this is not that you are taking a lot of effort. So for example, integrating Thousand Eyes, Catalyst Center, Meraki, and Nexus dashboards, you have technical add-ons in Splunk that help you bring data into Splunk. And then you have content packs on ITSI that help you work with that data in terms of alert correlations, the service health, and all these core objects, whether it's correlation rules for alerts, whether it's services, whether it's the KPI definition, or whether it's the model for entities, such as the actual network devices. All this comes pre-built as part of our content packs. And then we not just stop at just showcasing you the devices and the alert information, but we also give you a deep link for the deeper troubleshooting in RCA. In other words, if we identify that, hey, your issue is in the Catalyst Center, we give you a deep link or in-context link to land into Catalyst Center along with that context so that you can directly troubleshoot that inside of the Catalyst Center. With that, we talked about the service health as a whole, which includes the event management, alerting, as well as the KPI and the service health. Now, zooming into event analytics specifically, what we do is, as I mentioned earlier, we can take hundreds of thousands of alerts coming per minute from various systems, Splunk, Cisco, and third-party systems, and we apply 2 types of correlation technologies. We either do the machine learning-based correlations to group the alerts, or we also allow the rule-based correlation where the users can define the rules to correlate the alerts. These alerts get correlated, and we create what we call it as an episode, which think of that as an incident. These episodes can then be linked to your ITSM systems like ServiceNow to create tickets. you can actually do the bi-directional updates between Splunk and ServiceNow as well. Whether it's ServiceNow, Jira, BMC, we do support some of the well-known large ITSM players as well. And not just stop at just integrating with an ITSM system, but you can also integrate with incident response systems such as PagerDuty, Opsgenie, and also Splunk has its own offering called Splunk On Call for that very purpose. We are also natively able to integrate with an automation platform like Ansible, where once you identify an incident, you can execute a playbook in an automated fashion using Ansible, or you can run any programmable script to automate the actions. Last but not the least, you can then, you have your own ability to manage your incidents, episodes for investigation, resolution, and escalation within the product in our operational consoles. When it comes to the incident management itself, these are the steps that we follow. And some of these is what we will see when I hand it over to Matthew for the demonstration, right? Because then we are going to talk about how we do this. So the first step that we do is we ingest the alert data and normalize the alert data. Each third-party system or each monitoring system sends alerts in its own format because there is no general standardization. So what we do is we take alerts from which are in all these multi-format structures and normalize them into a single data model or data structure, which is Splunk and ITSI understandable. We extend the Splunk's common information model or the SIM model, and then basically apply the data model, normalization on top of that SIM model. If you or your organizations are more concerned about ITIL, then yes, this data structure or data model does follow ITIL very closely. Once the data is normalized, the second step is enriching and contextualizing the data. In other words, if you have alerts and incidents happening, you would want to know the decision of, hey, if it's a database issue, who should this be routed to? If it's an application issue, who should this be routed to, right? So those sort of decisions. And the second is the context. You can also enrich alerts inside of Splunk using the context from a CMDB like ServiceNow. You can bring CIs, relationships, changes, and outages related data and enrich the alert and contextualize that further. Get it ready for correlation, which is where the step 3 comes into play. Where, as I mentioned, we support machine learning-based techniques as well as the rule-based correlations to allow you to group and relate the alerts for cost-income relationship. And the last but not the least step is once the root cause is identified, the next step is we help you automate and remediate those incidents as well by integrating into automation systems such as Ansible. Right? So that's how we do the closed-loop incident management. And in that, these are basically the 4 steps. For step 1 and 2, which is the data normalization, we will see when Matthew will showcase the demo to us that we do provide a lot of such out-of-the-box integrations that you can see here on your screen. These are the checklists that allow you to onboard and normalize and enrich those alerts from various systems into a single click, right? So whether it's Nagios, SolarWinds, SCOM, AWS, and a lot of Cisco and Splunk tools, you have these things available. Now, what you see on the screen is, of course, not everything. So Matt will talk about it. We will see that we also are shortly planning to support Zabbix, Dynatrace, Datadog, Oracle Enterprise Monitoring, VMware, and a lot of these other third-party tools for a single-click alert onboarding and enrichment as well. The next thing from there is the event correlation or the grouping. As I mentioned earlier, we have 2 types of grouping. One is a standard rule-based. You define the correlation rules, and then we'll basically do the grouping based on that. And that experience is also fairly mature. But what we have recently introduced, and I shouldn't say recently, it's been out for about 6 to 8 months now, is what we call it as Event IQ. This is a machine learning algorithm which looks at your alerts and the alert metadata, and then based on that, it suggests you how you should be grouping those alerts. So it identifies the fields or the metadata on the alerts, and it gives you logical metadata that you can look at to correlate and group these alerts together. And that all that happens because the first step of data normalization or data enrichment is where we prepare the alert. And that's when the Event IQ makes it very easy to identify the right set of fields to correlate or the group on. Once the incident is created, that's when the next steps comes, which is what we call it as AI-directed troubleshooting and root cause analysis. That's where the event IQ gets extended for diagnosis as well. And here, we are not just looking at an incident as an incident, but we also look at the incident, and if you'll see it on the right side in the screenshot, that we summarize what an incident is about. We give you suspected root causes. We give you the next steps for those root causes. And we also give you a complete evidence timeline so that you can trust the AI-generated summaries output that we are showing you. Along with that, what this does is the event IQ diagnose piece is it actually looks at your Splunk alerts, the relevant logs, change data, CMDB topology data. So a lot of these contextual data it looks at, and you can also point it to any custom Splunk source. Like you can say that, hey, I have this Splunk index, which has a lot of additional data related to these domains. Please go look at that for your RC as well. So it's not just limited to the alerts and relevant logs for those entities, but it can also go look at the custom data sources that you can point the system to, and then give you the summarized outcome for your root cause analysis needs. All this can be exported in one click to ServiceNow as an incident, or I mean, I'm giving ServiceNow as an example, but it could be any ITSM system, whether it's ServiceNow, BMC, or Jira, right? Like these are the three most popular ones that we see. And then last but not the least, as I said earlier, you can have bidirectional integration with ITSM tools. You can have bidirectional integration with the notification system provider like PagerDuty and Splunk On-Call, and you can automate the remediation by integrating into Ansible. With Ansible specifically, if any of you are using Ansible automation platform or Ansible event-driven Ansible, we actually have out-of-the-box integration with those. In other words, what we help you with not only taking, like telling you that, okay, when this situation occurs, this is the playbook that you would execute. We also help you decide based on the alert signature that, hey, these are the relevant playbooks in Ansible. So you don't need to configure it. We will just pull that information out for you so that you can just do a quick selection on which playbook to run. With that, I will transition it to Matt, who will actually show us a lot of these things in the product, taking a couple of examples for the network tools. So Matt, over to you.
All right. Let me attempt to share the screen here. Right. Tapan, can you confirm that my screen is being shared? Because I can't see the sharing controls and the screen. Okay, cool. All right. So what we're looking here is the service analyzer on IT service intelligence, and so we've got a business here that we're monitoring, boutique company, and each one of these sort of dots on the topology, each one of these vertices represents a business service, a business unit, a business function. So if we break down the root company node, we see data center, online services, store revenue, and then store physical plant. And then those break down further into like the mobile app versus the website, and some additional further breakdown of stored infrastructure. So all of these services are custom use cases set up to monitor this business. But as we drill below that, we see service subtrees here for Nexus monitoring, Nexus dashboard, monitoring Splunk microservices and cloud native applications with Splunk Observability Cloud, traditional 3-tier applications with App Dynamics. We have Thousand Eyes monitoring for synthetic tests. And then we also have Catalyst Center monitoring our campus branch networks here. So here are all subtrees that are auto-generated based on data coming from these integrations and the ITSI content packs. So using the technical add-on for Nexus Dashboard, Catalyst Center, Thousand Eyes, Meraki, App Dynamics, etc., and the ITSI content packs, we're able to automatically build these subtrees to monitor your specific network infrastructure, your data center, your application, microservices or App Dynamics applications, as well as Thousand Eyes synthetic testing. And then you can attach those in the appropriate places with your business services to put that monitoring in context of your business. That way, when we actually have an event happening and reduce service health in Catalyst Center in this example, we can actually see the impact of that on the business. We also see an incident over here being raised from App Dynamics monitoring. If we go up to the root of this service tree for boutique company, we can actually use the service impact analysis tab in ITSI. And what this does is it takes a real-time analysis of service health across the entire service tree to determine which is the highest impact degraded service that is having the highest impact on the service health. And so where should you begin your root cause analysis and then eventual remediation? And so in this case, what this is raising is that our access layer in Catalyst Center is having issues, and that's the highest impact for the service health may ultimately be the cause of these application errors due to network problems over here. We can drill in here and see the actual affected entities. So in this case, this is a Catalyst Center building. And you can drill from here into a dashboard for that specific Catalyst Center. In this case, this is the floor of a building. And where we can get some additional data. So this is all part of the ITSI content pack that shows you CPU utilization, memory utilization, as well as additional device level health for the devices on this floor. So we can see here all these access layer APs are currently reporting reduced health. And we're not seeing any unreachable or management errors. So it's something else. If we actually click here, we can actually drill into these devices in Catalyst Center. So I'm not going to be able to access this instance in this demo network that we've got right now. But this is where we're actually able to take these impacted services and drive directly into context in the upstream service controller, so in this case, Catalyst Center. Another feature of the service tree that we can actually do is we can go into one of these services and see individual KPIs, right? So we've got KPIs broken down here for this Catalyst Center floor, so we can see our access points, access layer, distribution layer, wireless controller health. But the other thing that we see here is active incidents affecting these services and entities. So ITSI, in addition to sort of tracking, and monitoring real-time service health and metrics, does alert correlation and aggregation into episodes. And that was some of the stuff that Tapan was talking about earlier. So in this case, we see that we've got 3 episodes open that are affecting this service or entities related to this service. And in this case, we have over a roughly 26-hour period. We have over 1,000 alerts that have all been correlated into a single episode. So that's that alert noise reduction that ITSI provides for you. And if we drill into one of these alerts, we can actually get some more detail about what is the individual episode, what are the affected services and entities, and then we can begin to take action. So in this case, we see these Catalyst Center services that we expected based on what the service tree was telling us. So I'm looking at this same alert. Kind of not a little startled as to why those tabs aren't available in this view. Here we are. I'm not sure what I clicked on. But so then, in addition to service impact, we can see the events timeline. So this is that those 1,700 notable events, 1,700 individual alerts that have all been correlated into this one episode. So we can actually see the timeline of when those events are firing. So we can see this first alert came from the 80 e-commerce service. And then we have purchases, and then we're starting to see alerts related to the store revenue numbers that are reporting in. And then we also see those Catalyst Center alerts. And here we're able to see this is a possible root cause here based on the severity and the timeline. So when this alert came in, so this appears to be the first alert that came in here with a high severity, and so ITSI is suggesting this is a possible root cause. So you could take a look at this alert first, but we also see these other alerts as well. ITSI also, the episode and alerts also gives you these other tabs to view similar episodes previously, as well as take actions and see the actions that have been triggered on this alert. And so in reference to actions, so we can send this alert to create a ServiceNow incident, send it to Splunk on call, open this alert in Splunk Observability Cloud. We can link it to another ticket. So these are all actions that have been set up in this instance's ITSI. And these actions are customizable. So you can set up custom scripts, run SOAR workflows, send it to Thousand Eyes, trigger webhooks. All of these can be configured for your instance. Let's see. So now that we're talking about these alerts and the data normalization, I wanted to pop over here and take a look at what that means and what that looks like. So the ITSI content pack for enterprise networks provides this Catalyst alert template. And so this is a pre-built template that that ITSI provides out of the box for Catalyst Center data, tuned to the data brought in from the Catalyst Center technical add-on. So you configure the Catalyst Center technical add-on, it starts bringing in data. The ITSI content pack normalizes that data to the ITSI data model. And this is what we see here is that what that mapping kind of looks like for bringing Catalyst Center device alerts into ITSI. And if I pop one of these open here, this is a little more technical of a view of it, but here we see transformed alert that matches the ITSI data model from the raw event. So in this case, the transformation is it's not terribly different, but in some of our integrations, there's significant nesting and normalization that happens from these events to bring them into the ITSI alert event. But the nice thing is that once we do this, these fields in this alert are the same across all alert data sources for ITSI. And that's that sort of underlying data normalization and data model that powers the episode correlation and AI assisted event alert summarization and root cause analysis. All right, so let me go back here. Stop sharing my screen. Okay. Tapan, do you want to take back over?
Yes. Yes. Thank you, Matthew. And yeah, so I think what we saw in Matthew's environment started with a pretty much a retail-oriented use case. Use cases and solutions are not limited to just one industry, to many other industries. And what we've done here is just given you an example of if you're into financial industry, like you could apply these use cases for online banking, ATM branch, kind of monitoring across sites. You can even apply this to mobile banking and the transaction monitoring across networks and applications. If you're into manufacturing, you apply this as a solution for your factory and the production throughput related measurements. And then if you're a service provider, then you apply this for the visibility on the tenant level service health for the SLAs, right? So there are, and these are just the representative industries. By no means these are the only ones, right? Like we support any industry, but I'm just trying to kind of draw the parallel into what we saw versus what other such use cases you can extend this to is what I was trying to show you. Just to summarize, I think the reason why we say that you should use Splunk is one, it does provide the advanced correlation. It does have the rapid progression in terms of the root cause analysis and time to value, and then the flexible data access. That's kind of another key. You can bring data of any type, any format from any source into Splunk, and then eventually enhance your visibility, right? So all these facets, when they combine, it just makes an overall a very powerful solution. With that, if you need to follow any resources, we have also attached a bunch of reference websites that you can follow. Some of these are blogs and community posts. Some of these are product documentation links. And we also attach videos that just help you kind of understand the solution in depth. So with that, I think we are up for Q&A. I know Matthew has been answering some offline as well, but I think this is the time for you all to ask questions, and yes, we're happy to answer it. It seems like if you guys don't have any further questions, we can probably end it here. I hope this was all useful to you. You have a lot of reference links as part of the slide decks that will be shared with you all. If you need any further information, feel free to reach out to myself or Matthew. Thank you all for your time and, well, happy splunking.